Okay, so let's say that you work for a company where they invest certain amount of money, let's call it X, into advertising. And the last time they invested X into advertising, they got Y amount of sale, but they don't always invest the same X amount of money. Sometimes they invest X1, which yields Y1 sales, and sometimes they invest X2, which yields Y2 sales, and so on. So you will eventually get to analyze an amount of points um, for your boss. Now, boss wants to know how valuable it is for us to invest more and more money into advertising. It is actually contributing to higher sales or not. So what you do first, you will plot these numbers, right? You have an amount of pairs and you will plot them, and if they have increasing tendency, you will see that it's worth or not. But sometimes they are scattered like this and you don't really know what to think of that, because for example, when you invested this much, it yields this much sale, but even though you invested more, it still yields the same sale. So uh, what to think of it? Now what you have to do is to find a way to fit a straight line over the entire set of points with certain conditions. And if you see that this line is going up, you can say, despite these 2 points, we can say that on average, with increasing x, you will get increasing y. So let's have a look what's happening here. So let's say we have these 2 points, right? And this one here, and we had the straight line that had been used to fit this set of points. Now this, what you got when you invested x2 amount of money, you got this y2 amount of sales. This is your x and this is your y. But this line here is defined as a plus bx, right? That's how we define a straight line, a plus bx. And so when you take this x2 and when you plug it in here, you will get a certain value y with this hat. So this will be the value you will get. This will be, because it has to lay on the line, right? So this will be your y2 with this symbol. Now here you have your error. And what you have to do is to find a way how to take all of these differences here, right, and minimize them. So let's take them all. Let's take sum of all the points from I equals 1 to n, and let's find the difference between y for each of the points minus y for each of the points coming from the line itself, and square it all. Because for example here, if you take this value minus this value, this will give you a negative result. If you take this value minus this value, it will give you positive results. So square it all, you don't have to care about the signs anymore. And this is what it's called, method of least squares. It's a widely used principle for fitting straight lines through a set of points. So let's take this equation for what a line is supposed to be like and plug it here. So you will get here, you will get your sum y I minus a minus b x I, right, square. Let's call this whole thing as a RQ. Now we have y's and we have x's, those are inputs for us. Now what we need is to calculate a and b, because this is what we want. We want to get the equation for the line, which is in the form of a plus bx. So in order to minimize these least squares here, then we have to take that the partial derivative of q with respect to a has to be equal to 0, and we have to do the same for the b. Also it has to be equal to 0. So what do we get when we do it here? We get minus 2 times the sum of y I minus a minus bxi. And here we get minus 2 sum xi times yi minus a minus bxi. And as said before, these two have to be equal to 0. So let's now clean a little bit. Let's erase everything here that we don't need anymore, so we can continue our derivations and move everything up. And we can also get rid of this. So these are our two equations. So you see, if we have everything set in here for x and y values, we will get the set of two equations with two unknowns, and the unknowns being a and b. So if we take this all up, so we can continue here, we can say that to clean this up, we can get rid of these two minus 2's because this is equal to 0, so when you put them on the other side they can go. And what do we have here? Here we have the sum of all the y's, right, minus sum of all the a's, and minus sum of all the bxi's, and that's equals 0. And for the second equation we have a sum of all the xi times yi minus sum of all the xi's times the I minus sum of all the b times xi square equals 0. So if we clean this a little bit further, we can say here that, and take all the x's to one side, all the i's and b's to one side, everything that doesn't have I and b in it will go to the right side. So here we have a times n. That's this one. The a appeared n times there, right? The sum goes from 1 to n. So a is there n times. So a times n plus. Now the b can go in front of the sum xi. So everything with a's and b's is on the left. Everything that doesn't have a or b will go to the right. And that's the sum of all the y's. Again, we will do the same thing here. We have a x, sum of all the x's times the a, plus b, sum of all the x's squared, right? That's from here. And the one member that doesn't have any I or B in it will go to the right side, so there will be sum of all the x's multiplied by y's. So this is our, what is called, normal equations. So let's again do the same thing here. Let's delete everything that we don't need, and so we can actually solve some example. So I will leave these normal equations here, and let's put them up and solve this problem. For if our x value would be 1.3, it will yield a dependent variable of 0.103, and minus 0.1 will yield the dependent variable of y of 1.099. 0.2 will yield y of 0.8008, and 1.3 will yield 1.897. So when you actually plot these, you will see if this is your minus 1 and if this is your plus 1 and if this is your 2. For minus 1.3, somewhere here you will get this small value. For this x value you will get something above 1. maybe something below 1 you will get here, and something almost 2 you will get for 1.3. So these are your 4 points, and this will be something to expect a line like this. So what do we need? We need a sum of all the x's. Sum of all the x's here would be what? Minus 1.3 plus 1.3 is 0, minus 0.1 plus 0.2 will give us 0.1. And the same for y's, because we will need it here in the right hand side of the first equation. Sum of all the y's will be 3.907. So then we can go on. For example, here we need sum of all the xi squared, which will give us the value of 3.43, and sum of all the xi yy will give us the value of 2.3839. So when we take these 4 sums and we plug them here into our normal equations, we will get this system of 2 equations with 2 unknowns. It will be 4a plus 0.1b equals 3.907, and 0.1a plus 3.43b equals 2.3839. So this is our system of 2 equations with 2 unknowns, which will give us the values for a as 0.9601, and the value for b will be 0.667. So the equation for our line y will be a, which is 0.9601, plus b times x, which is 0.667 multiplied by x. So this is the solution to our set of points, which is here, and this is the line that can be used to fit all of them as a set.